In this video, we will talk about how to multiply two numbers in scientific notation. So I have three examples for us to work through here. Let's check out this first example. We have 2 times 10 to the fourth, and this whole expression is being multiplied by 3 times 10 to the fifth. So how can we multiply these two numbers together? Well, the trick is you first want to multiply the coefficients, so the numbers in front together. So 2 times 3. Then you want to multiply 10 to the fourth times 10 to the fifth. So when we do that, we get 2 times 3, that's 6. So we get 6 times. Now, when we're multiplying two numbers that both have the same base, so they both have a base of 10, all we have to do is add their exponents. So we'll say 4 plus 5, that's 9. So we get times 10 to the 9th power. So that is our final answer. All right, let's try another example. Let's say we have 4 times 10 to the third, and that's all multiplied by 6 times 10 to the 8th. So again, to multiply these two values in scientific notation, we will first multiply their coefficients, the numbers out front, and then we'll multiply the values with tens as the base. So we would get 4 times 6 is 24, and that's multiplied by 10 to the third times 10 to the 8th. Once again, they have the same base, so we're just going to add their exponents. So 3 plus 8 is 11. So we get 10 to the 11th. Now, for a number to be in proper scientific notation, the coefficient, the number out front, should be between 1 and 10. So we can see that 24 is not between 1 and 10, but we can easily convert it to be in the range of 1 to 10 by recognizing that the decimal place on 24 is right here. And if we just move that decimal place 1 to the left, we would get 2.4, which is between 1 and 10. So we could say 2.4, but we still want this value to be 24, so we don't actually want to change that value. So if we have 2.4, how can we keep that as 24? Well, we could just multiply it by 10, or 10 to the first, because 2.4 times 10 to the first, that is 24, and then we still have times 10 to the 11th. So we'll notice that we can simplify this expression since we have 10 to a power and 10 to another power. So if we add these two exponents, we get 1 plus 11 is 12. So our final answer is going to be 2.4 times 10 to the 12th. Now, one shortcut method that you might want to keep in mind is the number of places that you have to move the decimal place to the left is the number of values that you need to increase the exponent by. So we can see in this case, we move the decimal place once to the left, so we would need to increase this value of the exponent by 1, so 10 to the 12th. So that would be a shortcut way to arrive at this answer. And the opposite rule of thumb is that if you're moving a decimal place to the right, the number of places you move it to the right is the number of values that you decrease this exponent by. So that's just a rule of thumb that you might want to keep in your math tool belt. All right, let's try one more example. Let's say we have 3.1 times 10 to the fourth multiplied by 5.4 times 10 to the sixth. So again, we're going to multiply the coefficients out front together, and then we're going to multiply the numbers with base tens together. So this one is a little bit different because we're multiplying decimals. So here's the trick you can use when multiplying decimals. Count the number of values after the decimal place. So here's one value after the decimal point, and here's one more value after this decimal point. So that's two total values that occur after the decimal point. So what that means is when we multiply these values together, their product is going to have two total values after the decimal point. So here's what we can do. We can multiply these values and just ignore the decimal points for now. So we'll treat it as 31 times 54. And let's see what we get. So 4 times 1 is 4. 4 times 3 is 12. Put a 0 placeholder here. 5 times 1 is 5. And 5 times 3 is 15. So then we add these two rows together and we get 4 plus 0 is 4. 2 plus 5 is 7. 1 plus 5 is 6, and 1 plus nothing is 1. Now we said there will be two total values that come after the decimal place. So that means our decimal place must go right here in order for us to have two values after the decimal point. So 3.1 times 5.4 is 16.74. So let's write that over here. 16.74, and then we have times, we have 10 to the fourth and 10 to the sixth. So 4 plus 6, that's 10. So we get times 10 to the 10th. Now, again, we said for this number to be in proper scientific notation, this coefficient out front needs to be between 1 and 10. So right now it's not, but to get it between 1 and 10, we can move the decimal point 1 to the left to convert this to 1.674. And we said the number of places that we have to move the decimal point to the left is the number of values we have to increase the exponent by. So this 10 becomes an 11. So we'll say times 10 to the 11th. So that is our final answer on this one.